We are in type 3 now. Type 3 questions will be of this form. F of d into y equals to x power k. You will be given question in this form. Solve d square minus 4 into y equal to x square. Or you will get x cube plus x square plus x. In that way you will get one expression, algebraic expression. So we will consider operator form f of d, then auxiliary equation f of m equals to 0, m square minus 4 equal to 0, m square minus 2 square equals to 0, m plus 2 into m minus 2 equals to 0, m equals to minus 2 or m is equals to 2. Once we got this one, we can consider yc equals to complementary function c1 e power m1x plus c2 e power m2x. Once we get the value of yc, now we can go for yp. Yp equals to this, suppose this is yp, so this goes to the denominator, x square divided by d square minus 4. Now we can write this one as 1 by d square minus 4 into x square. What we have to do is, first we have to write this one by taking constant as first term, minus 4 plus d square into x square. Then take minus common, actually minus 4 common, so directly if you will take minus 4 common, then you may not take this minus sign. That's the reason, first take minus common, then take 4 common. 1 minus d square by 4 into x square. This is minus 1 by 4. This denominator consider to numerator. It becomes inverse and x square. The reason of taking is we have to bring this one in this form, 1 minus x form. If it has inverse, this is 1 plus x square plus so on. You have to check whether we have x square or x cube. If it has x square, you can expand till x square. So we will expand this one. 1 minus, this is x inverse, so 1 plus x square into x square. Now minus 1 by 4, 1 plus d square by 4. We are ignoring this d power 4. Reason is, see, d square of x square is derivative of x square. Derivative of x square is 2x. Now derivative of 2x is 2 outside, derivative of x is 1. So we are getting derivative of x square 2 times is equals to 2. If suppose if I want to derivate x square 3 times, what I will get? Derivative of x square. Derivative 2 times is 2. Then we will get 0. So if x square is there, we can differentiate 2 times, you will get constant. 3 times you will get 0. 4 times you will get 0. That's the reason we will ignore this d power 4. Now answer is, here this x square is there. So we can conclude here itself. Minus 1 by 4. 1 into x square is x square. 2 times derivative of x square is 2 divided by 4. This is our yp, particular integral. Therefore general solution is y equals to complementary function plus particular integral. So yc value you have to write here, then yp. Conclude this. To get correct idea regarding this one, you have to check some 3 to 4 questions of this kind. See, we have, this is operator form given to us. We will take f of d equals to d square plus d minus 2. Then auxiliary equation will be f of m equals to 0, m square plus m minus 2 equal to 0. 2 1 times 2. So factorize this one. If factorization is not possible, you can go for minus b plus or minus root finding formula. Quadratic equation we will get. So m minus 1, m minus 2 equal to 0. So m values are 1 and minus 2. Immediately you should write complementary function c1 e power m1x plus c2 e power m2x. After yc we will have yp. Yp equals to 2, I am multiplying to all the values there. divided by this d square plus d minus 2. One by d square plus d minus 2 into 2 plus 1 by d square plus d minus 2 into 2x minus 2x square. See why I have considered these two outside. Whenever any constant term is there, this is our type 1, constant into e power 0x. Those who have done type 1, they know this one. If we find any constant here, that is our yp1. This is yp. Now I will take yp1, part of it, this first part, 1 by d square plus d minus 2. 2 is there, we will write e power 0x along with this 2. 2 divided by e power 0. 0 is there means in place of d we will substitute 0. So this is 2 by minus 2, that is minus 1. yp1 we have. Now we can take yp2 in terms of whatever x terms are there, that is yp2. At the time of writing yp2, take constant as first term. Then write this as it is, 2x minus 2x square. Then what we will do, after writing constant we will take minus common. 2 minus, these two terms will take one bracket to it. Then 2x minus 2x square. Then we will take 2 common. 2 ones are 2. We need 1 here. 1 minus x inverse formula we need actually. This one is by 2. If I will take 2 common, here you will get 1. Then this 2 goes to the denominator. 2x minus 2x square. Now this is minus 1 by 2. This value will take to numerator. 1 minus d square plus d divided by 2 inverse into 2x minus 2x square. Then minus 1 by 2. 1 minus x inverse. 1 minus x inverse formula is 1 plus x square plus so on. Because highest degree is x square, you can expand till x square. So what I will get here, 1 plus this is x, this bracket is x, plus x square divided by this x square, 4. Consider this denominator also while squaring. So this is 2x minus 2x square. Now we will expand that. 1 plus this is d square by 2, this one is d by 2, a plus b whole square, a square plus b square plus 2ab divided by 4 into 2x minus 2x square. The terms more than power 2 is ignored, discarded. This one we need to discard that. Then 1 plus d square by 2 plus d by 2 plus d square by 4 into 2x minus 2x square. You can simplify d square d terms also, but without simplification also we can do. 1 we will multiply to this. 1 into 2x minus 2x square, 2x minus 2x square, plus 2 times of derivative for 2x, 0. 2 times of derivative of x square. See how we are getting that. 1 we are multiplying to this. 2x minus 2x square. Then plus d square by 2 I am multiplying to 2x minus 2x square. What I will get here? 2 times derivating to single x value means 0. 2 times derivating to x square. See, derivative of x square means first time derivative it is 2x. Second time if we will derivate 2 will get. So 2 times derivative of x square is 2. Then single we have derivated 0. This is 2. So what you will get? 0 minus 4. So after differentiating this one to these two values we will get minus 4. Now single derivative by 2, 2x minus 2x square. Derivating this x is 1. So what I will do is 2 d by 2 of x, 2 d by 2 of x square. 2 by 2 derivative of x is 1. 2 by 2 derivative of x square is 2x. 2 by 2 is 1, 2 by 2 is 1, this is 2x. So we'll get 1 minus 2x for this. Now 2 times derivating 2x minus 2x square. Check once again. D square by 4 is there, 2x minus 2x square. What I'll do, I'll take this 2 outside, d square for x. Then I'll take this 2 outside, d square for x square. 4 is there in the denominator. This is 1 by 2, derivating 2 times is 0. This is 2 by 4, derivating 2 times x square is how much? 2. So this will be 0 minus 4 by 4, minus 1. So this one is minus 1. So plus 1 minus 1 cancelled, plus 2x minus 2x cancelled. What I'll get? What I got? Minus 1 by 2 minus 2x square minus 4. So this is our yp2. Therefore y is equals to yc plus yp1. Already I have rubbed that one. This is yp2. This is our general solution. You can conclude by taking common and you can cancel. 2 common and cancel means what you'll get? X square plus 2 minus 2 common cancelled, so we will get x square plus 2 for yp2. After watching this video, you can practice in notes so that you can able to write in exam also. What we will get? F of d is d power 4 minus 2d cube plus d square. Auxiliary equation is f of m equal to 0. M power 4 minus 2m cube plus m square equal to 0. M square common, m square minus 2m plus 1 equal to 0. So m square equal to 0, or this is m minus 1 whole square. Whenever you find anything of this form, you can immediately think of this a minus b whole square formula. Here m is equals to 0 and 0, 2 values. Here you get m is equals to 1 and 1, 2 values. When m minus 1 whole square equal to 0, don't send that square to that side, don't make it root. Because m minus 1 2 times is there, you can get m minus 1 2 times. So one is m minus 1, other one is also m minus 1, m equals to 1. So when square is there, we'll get 2 values for this. So what is yc now? Yc equals to c1 plus c2x into e power repeated value plus 2 more repeated values are there. c2 is over, c3 plus c4x into e power m2x, second repeated value. So this will be c1 plus c2x into e power 0x. This is 1 anyhow. c3 plus c4x into e power m2x. This is 1x. So we got the value for yc. After yc, we will find yp. To find yp, what we will do? Yp equals to, this is yp, suppose. This goes to the denominator. 1 by d power 4 minus 2d cube plus d square into x cube. What we will do? We will take common first. D square common. So what you will get here? D power 2 minus 2d plus 1 into x cube. Now 1 by d square as it is into, here we will take constant first, d square minus 2d into x cube. Now 1 by d square, this is square bracket, so already 1 is there. Suppose any number means we can take number common and all. If we have a number, we can send this one to numerator. So this will be inverse of x cube. 1 plus x, this total 2 terms are x values. 1 plus x inverse is 1 minus x plus x square minus x cube, so on. Because here x cube is there, we have to expand till cube. So this 1 by d square as it is, 1 minus x plus x square minus x cube of x cube. Now we'll expand this. 1 by d square, 1 minus d square plus 2d, a minus b whole square, a square plus b square minus 2ab, then minus of means take common, a minus b whole cube, a cube minus b cube minus 3a square b, 3a square b. So how much you'll get? 6d power 5 plus 3a b square. B square means this is 4d square, 12d square into d square, 12d power 4 into x cube as it is. Because minus sign is there, we'll write 1 minus d square plus 2d plus d power 4 plus 4d square minus 4d cube minus d power 6 plus 8d cube plus 6d cube minus 12d power 4 of x cube. Now the terms which has highest degree other than cube, power 3 is there, power 3 degree, whatever highest degrees are there, ignore that. Now what we'll do, we'll have constant 1. How many d squares are there? Minus d square plus 4d square. So d terms, 2d, single 2d term, d square minus d square plus 4d square plus 3d square. Then d cube terms, minus 4d cube plus 8d cube, 4d cube plus 6d cube, 10d cube, x cube. Now derivating 3 times x cube. First time derivating you will get 3x square. Second time if you differentiate 2x into 3, 6x. Third time if you differentiate 6 we will get. So 1 by d square, 1 into x cube is x cube. 2 into derivative of x cube is 3x square. 3 into 2 times derivative of 2 times if you are derivating x cube you will get 6x. 10 into 3 times if you are deriving x cube, we will get 6. So this will be 1 by d square x cube plus 6x square plus 18x 60. Now this 1 by d is there still. So for d, 1 by d is integral. So 1 by d into 1 by d x cube, 6 into 1 by d x square, 18 into 1 by d x, 1 by d into 60. So this will be x power 4 by 4, x cube by 3, 18 into x square by 2, 60 of integral is 60x. Now again we are integrating this one, last step. 1 by 4, x power 4 by 5 by 5. Integrating this is 6 by 3 into x power 4 by 4, 18 by 2 into x power 3 by 3, and 60 into x power 1 is x power 2 by 2. This is the value for yp. Simplify and you can conclude y is equals to yc plus yp at the end. We'll add f of d first. F of d equals to d square minus 3d plus 2. Auxiliary equation is f of m equals to 0. M square minus 3m plus 2 equal to 0. 2 1 times 2 minus 2 minus 1m plus 2 equal to 0. M common m minus 2 minus 1 common m minus 2 equal to 0. M minus 1 into m minus 2 equal to 0. M equal to 1 or m equals to 2. Yc equals to c1 e power m1x plus c2 e power m2x. For yp, it is e power 4x plus sin 3x plus x square plus x divided by whole divided by. So this term you will get d square minus 3d plus 2. Second term we will get d square minus 3d plus 2. And third term we will take d square minus 3d plus 2. Clearly we find one thing here. One, first type, e value problems. Second, sin ax, cos ax problems. This is third type. So you will get revision of these 3 types here itself. Now we have first yp1 we will consider. Let yp1 equals to e power 4x. So first you have to write this one by taking 1 by e power 4x. So what we have, this 4 will substitute in place of d. 3 into 4 plus 2 e power 4x. So e power 4x divided by 16, 18 minus 12, 6. Now yp2 equals to sin 3x divided by d square minus 3d plus 2. So we can write this one as 1 by, and we'll write sin 3x here. We know that d square equals to minus a square, so minus 9. In place of d square we will take minus 9 minus 3d plus 2 sin 3x. So this will be 1 by minus 3d minus 7 sin 3x. You can take minus common, 1 by 3d plus 7. Because we don't have square here, so we need to rationalize this. 3d minus 7 by 3d minus 7 sin 3x. So it becomes minus 3d minus 7 divided by a plus b into a minus b, a square minus b square sin 3x as it is. Now d square we find. What is d square value? Minus 9. 9 9s are 81. Minus 81 minus 49 minus 130. So minus 3d minus 7 by minus 130. So we have sin 3x here. So 3 times of derivative of sin x is cos x into inner function derivative 3, 7 into sin 3x whole divided by 1 by 130. So you can conclude this one by writing 1 into this is 9, 1 by 130, 9 cos 3x minus 7 sin 3x. This is yp2. Second part. Once we got yp1 and yp2, we have third term also here. Let yp3 equals to, this is yp1, this is yp2 answer. Yp3 is how much? 1 by d square minus 3d plus 2 x square plus x. For algebraic terms, what I said you consider, we have to take constant first. 1 by 2 plus d square minus 3d in one bracket. Only we are taking constant as first term. See, we don't have any minus common, so directly 2 common. We need 1 as first term. If we are taking 2 common, here you will get 2 in the denominator. X square plus 1. Now 1 by 2, this one outside, this is 1 plus x. So it becomes 1 plus d square minus 3d by 2 inverse into x square plus x. Then 1 by 2, 1 plus x inverse, 1 minus x plus x square. Square means numerator square, denominator square. Because x square is the highest degree value we have, so we are not expanding it. 1 minus is given to first value, minus is given to second value, and denominator is given. Here a square plus b square minus 2ab, 2 into 3, 6 d cube divided by 4 into x square plus x. Ignore highest degree values. I am ignoring these two. So what I got? 1 by 2, 1 minus d square by 2 plus 3d by 2 plus 9d square by 4 into x square plus x. One is multiplied to both. 2 times of derivative of x square is 2. 2 times of derivative of x is 0. Then 3 by 2 derivative of x square is 2x. Then 3 by 2 derivative of x is 1 plus 9 by 4. 2 times derivative of x square is 2. 2 times derivative of x is 0. So this is our yp3 value. So what is the answer we have? Y is equals to yc plus yp1 plus yp2 plus yp3. One more you can check. F of d equals to d square plus 7d plus 10. Auxiliary equation is f of m equals to 0. M square plus 7m plus 10 equals to 0. 5 2 times 10, so 5m plus 2m plus 10 equals to 0. M common, m plus 5. 2 common, m plus 5 equals to 0. M plus 2 into m plus 5 equals to 0. M equals to minus 2 or m is equals to minus 5. So yc equals to c1 e power m1x plus c2 e power m2x. This is yc. For yp what we will do? We will take this 1 plus x divided by, we will write this term by taking constant as first value. You can take 1 plus x also directly. 10 common, 1 plus d square plus 7d divided by 10. So this is 1 by 10, this value 1 plus d square plus 7d divided by 10 inverse into 1 plus x. We have only one term here, so we can expand till one term. 1 plus x inverse is 1 minus x plus x square, so on. We will take only 1 minus x minus this bracket. This is x, so whole bracket we have, then 1 plus x. So what we will get? 1 by 10, 1 into 1 plus x, okay, or else you can d square by 10 plus into minus 7d by 10, 1 plus x. This is ignored. Now 1 into 1 plus x is 1 plus x, minus 7d, derivative of 1 is 0, x is 1, so minus 7 into 1 by 10. So this is our yp. Answer will be y is equals to yc plus yp. Okay, this is your type 3.